I once again welcome you all to the live session of week 5 for the week 5 content of Advanced Concrete Technology NPTEL course. I hope I'm audible to all. Let me share my screen now. Is my screen visible? Is my screen visible?
Yes,
Okay,
yes, ma'am, visible.
thank you. So, the last week we discussed some problem solving questions from uh, aggregates used in concrete and then chemical admixtures, particularly water reducing admixtures. In this live session, we'll be seeing questions from chemical admixtures part. Apart from water reducing admixtures, there are quite few other chemical admixtures used in concrete. So we'll see questions from that content, particularly from week 5 content. I hope you guys have watched a video before coming to the session. So now let's move to the live session. So this is the first question for the day. I have launched this question in polls. You can give your answer in polls as well. If you guys have any doubt regarding this week content, you can unmute it at any point of time while discussing the question, or after solving all the problem, all the questions taken. We have time about 5 to 10 minutes. We can discuss your queries regarding this week content. If I'm able to answer you guys, I'll answer, or else I'll answer you the next week. Okay, this is the first question, which I've already launched in polls. Please give. I request everyone to give your answer from polls. To the bottom right corner of your screen, there is an option called Activities. If you click that, you can find option called Polls. From that, you can find the question. Please give answer for question 1 alone. So I'll read out the question for you all. For the Abrams cone used for slump test, the ratio of top diameter to bottom diameter and the height. It's a type of cone. More as cones can say it's a frustum. There will be a top opening and a bottom opening, and there will be a height. So you have to find the ratio of the top diameter to bottom diameter and height. Let me start the timer. This question is very simple. So let me give you 30 seconds time to give the answer. If you're not able to give your answer in polls, please use chat box to give your answer. It's a very simple question. So, Adams cone we used to find the flow of concrete, like what is the slump value to find the workability, and then for self compacting concrete we used to find the flow of the concrete as well, how much it's spreading, and we use a hands up. We use a mini slump test to find the compatibility of SPs with cement paste. So a similar type of a miniature of a cone will be used for mini slump test. Okay, let's see the solution, and then we'll see what response we got from the class. So the ratio of the top diameter to bottom diameter and the height is nothing but 100 to 200 to 300, which is nothing but 1 is to 2 is to 3. That is the answer. So for the mini slump test as well, the same ratio is maintained. The top opening will be 20 mm, the bottom opening will be 40 mm, and then the height is around height is 60 mm. So totally the ratio will be 1 is to 2 is to 3 maintained for the mini slump test as well. Okay, so which is used to find the compatibility of cement paste. Okay, now let me see the class response before going to next question. Okay, 4 people have given the right answer. Thank you. Thank you for being attentive in the class. Okay, few people have answered in chat box as well. Okay, thank you. Now let's move to the next question. Next question is not launched in polls. You guys have to answer the question in chat box. So the next question is, so here there is a graph given. This is a research from Marsh Cone test. Okay, they have used three different types of superplasticizer, C1, C2, C3 with the cement. Okay, you have to find which superplasticizer is compatible with the cement used from the Marsh Cone test results. Okay, you have to find which is compatible and why. This particular result is taken from the class lecture which sir has already explained. So you guys, it should be easy for you guys if you watch the video. So you have to find which subplaster is compatible from the Marsh contest. There is a point which helps you find which is compatible. So let me start the timer now for a minute, or else I'll give you 2 minutes. Please write the answer why it is compatible. Okay, I'll read the chat box after 2 minutes. Take your time. And here the black line indicate is the flow measured after immediately after mixing initial, and the same paste is kept hold for a hour, like after 60 minutes again the same test is done. So here in the x-axis the SP dosage is kept on increasing, and with respect to that we have measured the flow time. So I request everyone to give your answer in chat box. To the people who join new, I'll repeat the question again. This particular graph shows the results from Marsh cone test, and this particular image is from the lecture which sir has already discussed in the video. So you have to tell which superplasticizer is compatible with the cement used. The superplasticizer C1, C2 and C3 is the superplasticizer used. Okay, you have to tell which particular superplasticizer is compatible. And why? How come you say which superplasticizer is compatible? Okay, time is up. Shall I stop sharing the screen? Or still someone needs some time? Okay, let me stop sharing the screen. Okay, C2. Okay, B or C2 both the same. Yeah, C2 slump in initial and after 60 minutes is merging. Yeah. Yeah, KPC Rao have given the correct explanation. Thank you. Your answer is right. So now let's get into the explanation part. Today I think from last class I could not hear like I feel the class is less attentive compared to the initial classes. Do you guys feel it boring? I didn't hear any response. Are you guys attentive in the class?
No, ma'am. Actually, we can't say boring, but the chemistry part has gone little bit more, ma'am, nowadays about the aggregate and the chemical admixtures. So I think that might be the reason, ma'am. It's like
Okay.
more complexity has come rather than the initial first week and second week, ma'am. What professor also said, ki the two chapters, the second chapter and the third chapter are very important, but that will be more related to chemistry part.
Okay. Okay. I got it. Okay. If you guys have any doubt or if you're not able to understand few points or you can ask me at any point of time. If I'm able to answer in the class, I'll answer, or else I'll give you the answer in the next class. Okay. Thank you for answering. I feel it very. I was very whether I'm making you guys bored or I don't know how to make you guys attentive. Thank you. Thank you. So let's move to the explanation part now. So point. Let me start. Take the pointer. Okay. So here you can see that first we will differ how come C1, C2, C3 differs. So here we can see that the initial and the after 60 minutes final thing is separate in C1. Okay, in C2 it's merging after a point of time, and in C3 it's merging, but it's not so good as C2. Okay, so this is the difference what we observe by seeing it. Okay, so if the SP is compatible with the cement, so how will identify it? That is KPC Ram has already answered in the chat box. So it should merge after a point of time, which is the optimum ratio. Okay, so it's optimum ratio. If you do mini slump test at this ratio, you will be able to attain mini slump test flow. Like, so the base is 40 mm, so it will spread up to 4 times more than 40 mm. That is 160 mm flow. 160 to 180 mm flow will be able to get with the mini slump test with the cement paste with optimum optimum SP ratio. Okay, so in C2, after a point of time, it's merging. That is a point we can identify that the SP is compatible with the cement. So the correct answer is option B, C2. Okay. Now let's move to next question. The next question, see, again you have to answer it in chat box. I have not launched this question in polls. Okay. Now let me read out the question. You have to find out the wrong statements. You have to find which are false. Okay. So more than one statement is wrong here. That's why I have not launched this question in polls. Let me read out the statements. The first statement is third generation high range water reducer requires a minimum of 50 mm slump for suitably acting on the cement paste. So they're saying that. Can anyone say an example for third generation high range water reducing admixture?
PC.
Sorry?
PC.
Okay, PC, yeah. Why what is can someone tell what is the working mechanism of third generation high range water reducing admixture? How it is different
Static
from the
hindrance.
past generations?
Steric hindrance.
Yeah, steric hindrance. In addition to charge
Electrostatic
impart,
repulsion.
charge imparting mechanism, it works on it has physical effect as well. That is steric hindrance. Okay, so they say that third generation high range water reducing admixture requires a minimum of 50 mm slump. Minimum, at least it should be 50 mm slump. Then only it can work on the cement paste. That is the first statement. Just think whether it's right or wrong. And then SNF is not suitable when the water to cement ratio is less than 0.35. They're saying SNF belongs to second generation high range water reducing admixture. They're saying that it will not work if the water to cement ratio of the system is less than 0.35. It can't work. And then option C is high range water reducing admixture added to reactive powder concrete is PCE. Reactive powder concrete has very low water to cement ratio. Very low in the sense even close to 0.2 or less than 0.2. So that is the expected water to cement ratio in reactor powder concrete. The strength of such concrete is very high. It's usually 100 to 200 megapascal compressive strength will be attained. They're saying that high range water reducing admixture added to this particular type of concrete is PCE, which is nothing but the third generation high range water reducing admixture. And then the option D is as the fineness of the cement increases, the optimum dosage of high range water reducing admixture decreases. Okay, so let me start the timer for a minute. Please give your answer in chat box. Sorry. Please pick out the wrong statements. Time is up. Let's see your response. Okay. Yeah, right. Higher fineness requires higher dosage. Yeah, right. That's right. Optimum dosage of high range water reducing should decreases. Okay, I was not able to connect. Yeah, A is wrong, B is right, C is right. Yeah, A and D are the wrong statements. Okay, thank you. Thank you for answering. So, let me take the pointer. Yeah, so we all know that third generation high range water reducing admixtures like PCE will even work on zero slump concrete, which does not even works with a very harsh concrete. Even if this slump is a zero slump, it can work. So first statement is wrong. And then coming to option B, yeah, it's true. It works from 0.35 to 0.4 water to cement ratio range SNF, so it's true. Coming to option C, yeah, it's true because reactor powder concrete will not have any slump and the water to cement ratio is also very less. So obviously, option C is true. And then coming to option D, fineness of cement increases means there will be more particles. The surface area will be very high, right? The specific surface area of the cement will be very high. If the fineness is if the cement is very fine, then the particle size will be very less. If the particle size becomes very less, then the specific surface area will be much high. So we need higher dosages of water reducing admixtures. So optimum dosage will not decrease; it will increase. Okay, most of you given the right answer. Now let's move to next question. Moving to question 3. Question 3 also I have not launched in polls. So please give your answer in uh, cha- chat box. Let me start the timer now for 2 minutes. After 2 minutes, let's see the answer. So we have to, if you have seen, there are totally 5 different types of set controlling agents. They have classified it. Okay, type 1, type 2, type 3, type 4, type 5. Okay, so if you know that, you'll be able to match it. If you know what is about type 3 set controller and what is type 4 set controller, you will be able to match it. And they have asked, coming to question 3, they are asking what if a monovalent cation is present in the set controlling agent, what action you can expect. And then what if a monovalent anion is present in the set controlling agent, what you can expect as an action in the cement paste if you add it as a set controlling agent. So that is the question. Please give your answer in chat box. Let me wait for some time and then we'll see the answer. Time is up. Let's see your response. Okay. Okay, only 3 of you have given your answers. Okay, let's see what is the right answer. So before going to the answer, let's see what is type 3. So you can see that here this particular graph I took from the from the lecture video, and then this particular slide is also from the lecture video. So here we can see that coming to type 1, we can see that with by increasing the admixture concentration, we can see that the initial setting time increases. And coming to type 2, initially if you keep on increasing the concentration, it increases the setting time, but after a point of time it starts decreasing. So, and then coming to type 3 as well, initially it keeps on increasing, and if you further increase the dosage at one point of time, the setting time will increase. So at lower dosage it will act as a retarder, but later it will act as an accelerator. Okay, so that is about the set controlling agents. And type 4 also, if you keep on increasing the dosages, it increases the setting time. So from here you can find the type 3 at lower dosage it acts as a retarder, and at higher dosage it acts as an accelerator. So but type 4 set controller acts as a retarder if you keep on increasing the admixture concentration. Okay, so and coming to type 5, if you keep on increasing the concentration, it will obviously uh, decrease the setting time. So it will act as an accelerator. Okay, so and coming to the presence of monovalent cations and monovalent anions. So coming to monovalent cations, so if there is monovalent cations, positive ions in the admixture, so obviously it will reduce the solubility of calcium, which is a positive ion, and it will automatically promotes the dissolution of silicates and aluminates, which has opposite sign. Okay, so at lower concentration, obviously it will decrease the solubility of calcium, but at higher concentration it will promote the dissolution of silicates and aluminates. Okay, so and coming to monovalent anions, it's a negative ions. So obviously it will reduce the solubility of negative ions, which is something but silicates and aluminates. It will reduce solubility, and it will promote the dissolution of calcium. So at lower concentration it will reduce the solubility of silicates and aluminates, and at higher concentration it will promote the dissolution of calcium. Okay, so this is the uh, uh, this is what given in the left side. Now we have to see what is in the right side. So obviously type 3 set controlling agent, at lower dosage it will act as a retarder at small dosages. That is the right answer. Nothing but 1 matches to B. And coming to second one, type 4 set controller, it is nothing but glucone is one such example of type 4 set controller. Okay, and then coming to third one, the monovalent cation, obviously it will uh, reduce the dissolution of calcium ions. And then they've given only calcium ions, so we have to think about which one will reduce the dissolution. So cations are positive ions, so obviously it will reduce the dissolution of calcium ions, and monovalent anions is a negative ion, so obviously it will increase the dissolution of calcium ions. Okay, I hope you guys got it right and you have answered correctly. Now let's move to next question. So you have to answer it. I have launched this question in polls. I have launched it as two questions, 4.1 and 4.2. Please answer the question in chat box. Let me start the timer. Okay, let me read the question, start the timer. So you have to find, if see, obviously we'll plan the mix design in table, and then we'll move to field. But in field, we can't say temperature should be only 27 degrees Celsius, room temperature. No, right? The temperature will decrease or increase. It is subjected to correction. It will change at any point of time. So as the temperature increases, what will happen to the optimum dosage of SP? So I have worked in lab. So we have worked at 27 degrees Celsius in lab, and now we are moving to field where the temperature is 40 degrees Celsius. Okay, so it's hot summer in Chennai, so we can expect more than 40 degrees Celsius. So what happens to the optimum dosage of SP? If it's say if it's 1%, optimum dosage comes to be 1%. Will this optimum dosage will increase or decrease? That is part one, and then in second one you have to say what happens to some slump retention ability. How long will the slump will be retained? So we have to think about the optimum dosage of SP as well as the slump retention ability of the optimum dosage. Okay, so let me start the timer now for a minute. After a minute we'll see the answer. Please give your answer in polls. Let's see after a minute. I could see around 11 people in class. Please, everyone try to give your answer. No one knows who gives the answer right or wrong. So please, everyone try to give your answer in polls. Okay, time is up. Okay, increase and decrease. Okay, people are given it in chat box. Okay, one has the decrease and increase. Okay, but mostly people are given it as increase and decrease. Okay, now let me see the polls as well. Okay, for the first question, no one has given the answer 4-1, but for 2, you guys have given the answer. Okay, let me end the poll for question 1, and then for fourth question also let me stop the poll. I have not launched 4-1. Sorry. Oh, I made a mistake. Sorry. I'm not launched the question at all. Sorry. Let me end the poll now. Okay. Okay. Getting back to the slides. So as I've already explained, so keep on thinking how what happens to the optimal dosage of SP. Obviously, the optimum dosage will increase, and then the slump retention ability will be decreasing. Okay, so if you plan something in lab, it is subjected to correction because the field conditions will not be similar to lab conditions. Okay, now let's move to next question. Let me check once that whether I have launched the question in polls one time. Yeah. Yeah, 5-1 also I've launched, and 5-2 as well as I launched. Yeah. Please give your answer for question 5 in polls. To the bottom right corner of the screen, there is an option called activities. If you click that, there is an option called polls. From that, you can find the questions launched. Okay. So if you guys using mobile phone, so here there is option called more options, right? If you click that, you will be able to find activities in it. From there, you can find polls. Okay. So now let me get back to the slides. Question 5. Let me read out the question. So already I've discussed what is type 1, type 2, type 3, type 4, type 5 type of set controlling agents. So now you have to find sodium silicate is accelerating or retarding chemical admixture, and as well as phosphonates. Okay. So you have to find this what is like which one is an example of accelerating and which one is an example of retarding admixture. Well, both can be retarding or both can be accelerating as well. So please give your answer in chat box or polls. Try to give your answer in polls. Okay, time is up. Let's see the poll's response. Okay, one is accelerating and retarding. Okay, you guys have already given the answer. Okay, that's fine. So it's a very simple question. So now let's move to the next question. So sodium citrate is nothing but an accelerating chemical admixture, and phosphonate is a retarding chemical admixture. Okay, now let's move to question 6. Question 6 is a true or false question. I have already launched this question in polls. Please find the question in polls and give your answer. So here the question is the SNF formulations, sulfated naphthalene formaldehyde formulations, are blended with the lignosulfonates for slump retention. Okay, let me start the timer now. SNF is a second generation water reducing admixture, and lignosulfonates is a modified lignosulfonates are used for as first generation water reducing admixtures. Here they are saying that SNF is blended with lignosulfonates for slump retention. Is it true or false? Please give your answer in polls. Both are water reducing admixtures here. One is from second generation, one is from first generation. I think the question is very simple. Let me see your response from polls. Yeah, it's true. Many people are given the answer already. Okay, so I think the polls response should be similar. Let me end the poll for question 5 and then see the response. Yeah, it's true and it's not false. SNF formulations are blended with lignosulfonates for slump retention. Because SNF and lignosulfonates are both are compatible. Can someone say is SNF compatible with PC type admixture?
Yes, ma'am, it is compatible.
SNF is compatible with PCE.
Yes, ma'am. SNF is compatible with PC admixture,
Okay,
suitable for bleeding purpose.
but in the lecture, sir has explained that SNF is not compatible with PC. That is one of the shortcomings of SNF type admixture. But lignosulfonates is compatible with PCE. Okay.
Yes, ma'am. Lignosulfate is compatible both with both SNF and PC.
Yeah.
Yes, ma'am.
But SNF is not that compatible with PC. Okay.
Yes, ma'am. It's true.
Yeah. Thank you. Uh, because I also used to, after listening to lectures and taken this course as my coursework in my PhD career. So I know that we were able to, we can make mistakes and we make mistakes, and from mistakes only we learn. So don't be hesitant to answer in the class, and feel free to to speak out in this class. Okay. So now let's move to next question. So questions are already launched in polls. It's also again a true or false question. Yeah. Coming to question 7. The question 7 is the lignosulfonate formulation are blended with TEA, triethanolamine, to reduce the effect of retardation. Okay. So first, lignosulfonate is the first generation water reducing admixture. Here they are saying TEA. So you have to find whether TEA is a retarder or accelerator. So if it's a retarder, then obviously it can reduce the effect of retardation, but we don't know whether TEA is an accelerator or retarder. So you have to find whether it's true or false. After a minute, we'll see the answer. Okay. Please give an answer in polls or chat box. Time is up. Let's see the response. Yeah. So more votes for true and one vote for false. Okay. Coming to chat box. T is an accelerator. Yeah, true. T is an accelerator. So obviously, will it reduce retardation effect? Okay. Can someone say what is a retarder and what is an accelerator? With respect to setting time. Can someone say what if you add an accelerator, what will happen to the setting time? And if you add retarder, what will happen to the setting time? It's a very simple question.
Accelerator will enhance the setting time, ma'am. That is, it will speed up the setting time.
Okay.
Retarder will basically reduce it. It will give more time for workability.
Yeah, true. Thank you, KPC Rao. So, if you add accelerator, it will accelerate the hydration process. So, it will reduce the setting time. Okay. So, if you add a retarder, it will increase the setting time. It will take more time to set. Okay. So TEA, triethanol amine, is an accelerator. So obviously, it will not produce any retardation effect, even if you add it to, even if you add it along with a water reducing admixture. So lignosulfonate is also it's also a type of retarder because it's a one it's type, I think, lignosulfonates is a type 4 type of set controlling agent, which is an retarder at higher dosages. So if lignosulfone is added lower dosages, it will act as a water reducing admixture. But if you add it higher concentration, it will produce air entraining and then as well as it will retard the reaction. So we have to be very concerned about the dosages of lignosulfonates used. So that's why for high range water reducing admixtures, we do not use higher dosage of lignosulfonates. Okay, so the correct answer is false. The statement is not true. Now let's move to question 8. Question 8, you guys have to answer this question in chat box. I have not launched this question in polls. It's a fill in the type of question. So now let me start. Okay, let me read the question, start the timer. Here they're saying that the first generation high range water reducing admixtures need a slump of around dash for action. So they're saying that first generation high range water reducing admixtures like lignosulfonates need a minimum slump of the concrete to work on, or else it will not work for the type of slump concrete. So I can say, for example, it will not work for zero slump concrete. Only third generation type of high range water reducing admixtures like TC can work on zero slump concrete as discussed earlier. So what is the minimum slump of concrete required for first generation high range water reducing admixtures to act? And then part 2 is the use of third generation high range water reducing admixtures increases slump to more than how much? It can even, if you say that the slump of concrete without SPs around say 150 mm, how much it can increase up to? We can forget about the slump. If it is a zero slump concrete, how much we can increase up to? So the maximum slump is 300 mm. So the slump height is 300 mm. So how much it can increase up to? Let me start the timer. Please fill your answer in chat box. We'll see the answer after a minute. Time is up. So, okay, 75 mm first generation. Yeah, it's true. Yeah, more than 250 mm. That's also right. Yeah. Okay, 75 to 50. Yeah, most of you have given the right answer. So now let me check the. Okay, now let's move to the slides again. So most have given the right answer. So here, sir has already explained the range of action. Coming to the first generation water reducers, high range water reducers, we need a slump at least of 75 mm for it to act, and then there is water to cement ratio of the system as well. It can work up to systems only for 0.45 water to cement ratio, and then coming to second generation, even it can work up to 0.35 water to cement ratio, and then it can third range high range water reducing admixtures can even work for very less water to cement ratio systems, and then we can increase the sample even more than 250 mm. Okay, and then it can even work on zero slump concrete as well, and then even increase the slump up to 250 mm. Okay, now let's move to next question. But the correct answer is first generation high range water reducing admixtures requires a minimum slump of 75 mm to act, and then third range high range water reducing admixtures can increase slump even more up to more than 250 mm. More than 250 mm. Okay, coming to question 9. Question 9 also you have to give the answer in chat box. Okay, so you have to pick up the statements which are true. Okay, leave out the wrong statements and please put the statements which are correct. Okay, let me read out the statements for you. Salts of weak bases and strong acids act as accelerator at higher concentration. Okay, so they're saying that salts which have weak bases and then strong acids act as accelerator at higher concentration. And then option B is our entrainers have hydrophilic hydrocarbon chain. Okay, so and then option C is for proper air entrainment, the distance between the voids must not be greater than 0.2 mm or 200 micron. Okay, so for proper air entrainment, the distance between two voids should not be greater than 0.2 mm. And then paste with lignosulfonate cannot achieve a flow similar to the paste with PCE even though the optimum dosage of lignosulfonate is higher. So here they're saying that paste, if it has a lignosulfonate, it can't achieve similar flow as PCE can achieve with the same paste. Even the optimum dosage of lignosulfonate is higher. Like if you say that if the cement paste is same, if you're taking 1% PCE and 1% lignosulfonates, they're saying that PCE, the flow with PCE will be higher. Even if you increase the dosage of lignosulfonates, you can't increase it. You can't increase the flow of the cement paste. Okay, so let me start the timer now and see the explanation and see the right answer then. Time is up, so let's see the class response and see the correct answer and explanation. So A, C, D true. Okay. Okay. People have given B, C, D, A, D. Okay. Okay. Most of you have picked up A, D as true. So let's see what is the right answer. Let me change the pointer. Why you guys think that C is not true? Few people have opted only for A and D, not C. So if for proper air entrainment in the case, so why we do air entrainment? Mostly in cold weather concreting, we go for air entrainment. So why do we do that? And if you have to reduce the weight of the concrete, we use air entrainment as an option so that we can reduce the weight of the concrete. And then air entrainment will also increase the workability. So for, as discussed in the lecture, we can use it for plastering purpose. So for particularly air entrainment is done in cold weather concreting so that it will have enough space for the freeze. If water freezes, we know that the volume increases. No, so if there is increase in volume, then there should be enough space for the increase in volume to uh, like water on freezing, the volume will increase, then we should have more space for to accommodate that, right? So on freezing, obviously the if a particular port starts freezing, then the water from the particular port should travel uh, to accommodate more space, right? So that travel time will be minimized. The traveling through the very small ports, capillary ports, will obviously increase the capillary tension. That will lead to failure of the cement paste. So to reduce the time of travel from one port to another port, if there is voids, air entrainment, and then the distance between the voids is not more than 200 micron or 0.2 mm, then the water need not travel much distance from one port to another port. Obviously, it will reduce the capillary tension, and then it will help cold weather concrete in cold weather region. So obviously, option C is true, and which is explained in the lecture as well. And coming to option B, and here option B is only false. All other statements are true. So salts of weak base and strong acids, the main example is calcium chloride or calcium nitrate, which is an example of an accelerator at higher concentration. And coming to option B, air entrainers, obviously the chain is a hydrophobic chain with polar group only at the end. Okay, so obviously air entrainer is not a hydrophilic hydrocarbon chain, so that is a false statement. Okay, so rest of the things is clear for you, I guess. So now let's move to next question.
Ma'am, can you please
Yeah.
again tell regarding this hydrophilic, ma'am? Because I was thinking this was the right, because sir was drawing that thing and telling that for the air entrainers it is the hydrophobic only. Hydrophilic.
Hydrophobic, not hydrophilic. Hello.
Because in that slide, ma'am, it was written that the hydrophilic polar groups are similar to water reducers.
Okay.
When
So
sir was telling, ma'am,
okay.
sir was drawing, and he was telling that all the chains will be having the polar this thing, and negative values will be there.
Yeah, that is for water reduces. So okay, I don't know whether I will be able to draw it now. Let me try to draw for you. Just a minute. Change it to, yeah, dark blue. Okay. So see, if it's a water reducer, there will be a long chain back polymer, and then there will be side chains, right?
Yes, ma'am.
The side chains will have negative sign, right?
Yes, ma'am.
So the whole chain will have some. So it has some charge, right? So it's not hydro. What happens is it will surround the cement particle. If the cement particle is here, then obviously it will surround the cement particle, and it will impart negative charge, right?
Yes, ma'am.
So it's not it's not hydrophilic. So it's hydrophobic.
Okay, ma'am.
It separates from water, and it gives more water, though, so that the cement paste will be more workable. There will be free water. So what happens is, see, there will be more cement particles here. So obviously the polymer, water reducing admixtures, the polymers will surround the cement particles. Then there will be free water to move. So it's hydrophobic. Okay. But coming to air entrainers, it will not have any charge, and the polymer will not have any charge. Okay, only in the one end, particular end, there will be a polar group. Okay, so
Okay, ma'am.
obviously,
Hydrophobic and hydrophilic. Okay, ma'am.
yeah, so it's hydrophilic. I hope you got it right. And then still we have one more question to discuss. After that, if you still we need to discuss, we can discuss. Yeah, let me finish that question. Yeah. No, questions 10, I've already launched the question in polls. Please give your answer in polls. So the question 10, it's an assertion reasoning type of question. So the assertion is VMA enhances, this is a statement and this is a reason. So you have to find whether the statement is true or false and whether the reasonings, whether the statement, second statement, reasoning statement clearly explains the first statement. Okay. So VMA enhances the stability of the mixes prone to segregation. You know that viscosity modifying agents, right? When we usually use it, when we'll use it, just think about it. Sorry, I was about to tell the answer. So VMA, the statement is VMA enhances stability of the mixes prone to segregation. They're saying that if cement paste is prone to segregation, if you use it, it will enhance the stability. And then the reasoning is VMA or long chain water soluble polysaccharides and enhance the water retention capacity of paste. Okay. So now we have to say which one. If you are picking option A, you are saying that both assertion reasoning are true, and or explains clearly the reason for A. Reason is properly explaining the statement A. And if you're picking B, you're saying that option A and R are both assertion reasoning are true, but reasoning is not or like reasoning. The second statement does not clearly explain the first statement. Remaining are, I think, very clear. Please give your answer in polls or chat box. Let me wait for some time and see the response. Okay, time is up. Let's see the response. Okay, option A, B, then option A. Okay, more option A and few option Bs. Okay, let's see the chat box one. Sorry, polls ones. Let me end the poll for other questions as well. Okay, more votes for option A. Let's see what is the right answer. So the right answer is nothing but option A, because the viscosity modifying agents or long chain water soluble polysaccharides which are absorbed to water and then increase the viscosity and forms gel type of things, which further increases the viscosity and then which helps to enhance the stability and helps against segregation. Okay, so someone who asked doubt regarding this question, are you able to get it right?
Understood, ma'am, regarding hydrophilic and hydrophobic, ma'am. Actually, I got confused with hydrophobic.
Yeah. Uh, hydrophobic is doesn't like water. It will be away from water, or else it will tend towards non. Hydrophobic is it's not okay with water, and hydrophilic means it's okay with water. I'm not able to clearly explain in technical terms, but hydrophobic, it doesn't like water. It will tend towards the direction opposite to water. Okay, so the hydrophobic can try to be okay. Let me try to turn on the pen again. So if there is an air bubble here, and this assume this is towards the cement, so the hydro the polar group will be tend towards the cement grains, and then this hydrophilic end will be towards the air bubble. So this hydrophilic, there will be more uh, so that so this hydrophobic chain polymer chain tries to keep the air bubble intact, intact even while mixing and compacting. Not the big air bubbles, but the very small air bubbles. They try to keep the structure of the air bubble intact. That's how air trainers work. This is the hydrophobic end, and this is the polar group in the opposite direction. Okay, I hope you guys got it right. If you guys have any doubts, you can ask me now. Sorry for the poor drawing here. Do you guys have any other doubt? So as talked earlier, you guys told that the content initially it was very easy to follow, and then getting to like now the cement chemistry part and then this chemical admixture part is difficult to follow. It will be like that, but once you get to understand these terms, you'll be able to better understand the concrete. So once I completed this advanced concrete technology course, I felt so overwhelming that I was able to understand few things I never able to understand about concrete. So I started respecting concrete more once I've completed this advanced concrete technology course. It was so helpful for me. So I hope you guys are also able to follow the class and then able to follow as well. If you guys have any doubt, please rise in the class. And then we have live session on Monday as well as on Tuesday. And then you guys have totally 3 live sessions with with the course coordinator. Already 1 live session is over. Still, you guys have 2 more live sessions along with the course coordinator. And then apart from that, you can write in discussion forum. I think recently we're not able to answer the questions in discussion forum, but soon you will guys able to find the questions, answer for the questions you have raised in the discussion forum. Okay, please feel free to write in the discussion forum as well, so that everyone who else have the same doubt will be able to clarify it. Okay, let me wind up the class here. Thank you once again.